ओके, गुड मॉर्निंग। आज हम लोग डिस्कस करेंगे रिगार्डिंग द सेंसिटिविटी कैलिब्रेशन इन फेज सिस्टम along with the practical video. The sensitive calibration, why it is required and how it is conducted. हमारा आज का डिस्कशन रहेगा. In this video we will learn how the sensitivity calibration is done and what is the requirement of sensitivity calibration. Basically we know that phased array system में we are using the multiple group to cover our inspection part, और एक पर्टिकुलर ग्रुप में हमारा जितना भी फोकल लॉस होता है that focal laws are differ in their angle. Suppose in sectorial beam formation we are using the minimum angle of say 38 degree and maximum angle of 68 or 70 degree. So due to the angle changes, if we are considering a unique defect in a standard depth, say the 1.5 mm side drill hole in a IIWV1 block, which is normally in a 15 mm depth. But when the same defect will be struck by the 38 degree focal law, so the beam path for the 38 degree and the beam path for the 68 degree both will be changes. But the defect size is same and the depth is same. So if what will happen, the returned amplitude from the 38 degree focal will be much more higher because the beam path is less. But if the angle is higher, the beam path will be high, and if the beam path will high, so from the same reflector, what will happen? The reflected energy will be less. Say from the 38 degree focal we are getting the 80% response from 1.5 mm side drill hole of IIWV1 block at a reference dB of 40. And if we are considering the same dB and the striking angle is 68 degree focal, then what will happen? The returned amplitude will be less than 80%. So if we are considering that 80% echo is the size of 1.5 mm side drill hole, then the sizing of the defect will be wrong in different focal. So how it will be compensated? That compensation is done with the help of sensitivity calibration. तो sensitivity calibration में each and every return signal from the different focal laws इसको हम लोग equalized करते हैं. और ये जो equalization कब होगा? Suppose 68 degree focal law में जो return amplitude है, say it's the 70%, and जो 38 degree का return amplitude है वो है 80%. So how we can increase the 70% echo height to 80% echo height? Definitely we need to add the dB values. So what will be the dB required for that compensation? That compensation is done by our sensitivity wizards function in phased array system. So after the calibration of sensitivity, if you are using that the 38 degree focal as a reference dB of 40 and the 68 degree or 70 degree focal has a higher dB value, so what will be the difference between the initial angle and final echo, final angle? That compensation is done by the process of sensitivity calibration. That means angle correction with respect to the reflector. So that's why the sensitivity calibration is also known as the angle normalization. That is also known as the ACG calibration. So what is the purpose? Now, sensitivity calibration in phased array normalize the response across the all focal laws. So it compensates for the element to element sensitivity variation, and that is the main purpose of sensitivity calibration. So what we will do? Now we will take the response from all the focal laws from a particular reflector, say 1.5 mm side drill hole from the IIWV1 block, and we will equalize the amplitude of each and individual focal by the calibration wizard of sensitivity. Now you can see these corresponding videos जिसमें आपको समझ में आएगा जो how we will carry out the sensitivity calibration in the practicalities. Okay, thank you. Proceed for the video.
हेलो। हाँ, मेरे पास है फ़ोन।